Alright, so for some requests made by you all, I'm going to do a video here with a couple Lewis structures. I'm going to do 2 Lewis structures, and you asked for the ones I thought would be most difficult. So pretty much what you guys are asking in class is what I'm going to go with here. So this first one I'm going to do is this organic molecule. So we're going to start with it, and we're going to do it in red. And with these, don't get caught up on this. CH3, CH2, CCl2, CH3. Don't get caught up on this. Just read it like you're reading a book. Just read it left or right. Okay, start with the left. So we're going to start with this carbon. We got CH3, so we know it's going to be a carbon with 3 hydrogens. How do I know carbon's in the center? Carbon's in that center because hydrogen will never be your center. Why will hydrogen never be the center? Because hydrogen just wants to make one bond. One bond will fill the 1s subshell. And once it fills that first energy level. Because remember, there is no p orbitals inside of that first energy level. So now, these hydrogens are done. They don't need a full octet. This carbon does though, so it's going to make another bond. And we're going to come here to the CH2. So it's going to bond with this carbon. And then, like I said before, these hydrogens will bond with this carbon. It will not bond over in the center, stretching us out. Same reason as what I stated before. Then we're going to go after this, and we're going to go straight to this next carbon, and next here we see these chlorines. Now, like I've said in class, halogens typically you'll see, those are the group 17, you'll typically will not see them being in the center. They do not like to be the center. They like to make one bond, get a full octet, they're happy, they're good, go lucky, whatever you want to say. I mean, they're just done. So, these chlorines will bond to this carbon, and there's 2 of them. So they'll bond there. And then we're going to finish off with the CH3, and it's the same thing like we started. Same reasoning why. Now, don't make a mistake. I'm having you do this for a reason. Many of you will stop here. Make for sure and carry it out. Give this chlorine the full octet. They both need 3 lone pairs. Make for sure and give those 3 lone pairs to them. Alright? So, there's that for an example. Now moving on, I'm doing one of these polyatomics ions that I've given you that you have got to start memorizing. You better have them memorized by the time we start nomenclature, or it's going to be a struggle. You're going to be struggle busting through the whole thing. So, the one I chose to do is nitrate because it's a really good example. So, we're going to start with nitrate. So, the first step, remember, follow your steps. First step, you're going to find what is your center atom. Your center atom, in this case, is nitrogen. How do I know it's nitrogen? Because the one with the lowest electronegativity would be the one in the center. Go back, review over your notes if you cannot remember the trend for electronegativity. You've got to know that. So, nitrogen's the center, and it's bonded to these oxygens. So now I have my skeleton, and now give everything a full octet. Everything wants a full octet here. So these oxygen, they need 3 lone pairs. And then nitrogen needs 1 lone pair. Now you need to calculate up how many of these valence electrons you have to show. So I like to do my little chart on the right like we did in class. So let's make me a little chart. I got nitrogen and oxygen. We'll start with nitrogen. I have 1 nitrogen. And for every nitrogen I get 5 valence electrons. So there's 5. 1 times 5 is 5. And oxygen, I have 3 oxygens, but for every oxygen I get 6 valence electrons. Okay, so that's 18. I add that together. Give me 23. Don't forget the charge. What I told you in class. Just in this case, with the rules and the steps we're following, use that charge, add 1, add an electron to this. So we're supposed to be showing 24 electrons. Now you need to go through and count and make for sure that you're showing 24. 24 electrons. You need to make for sure. So this right here, that's the whole purpose of doing that. Now, go through and count and see. I'm going to count by 2s, you can count by 1. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 24, 26. I'm showing 2 too many. So, like we went over time and time again in class, what do we got to do to fix this? That's right, you got to double bond that thing. So let's double bond. Now, I'm going to pick over on this left one just because that's where I typically like to start with my double bonds. Once you've done that, you better not forget that you have got to take away those electrons. You cannot break this octet rule. And wherever you put this bond at, you now need to take lone pairs away. Unless it's an exception and it can break the octet rule, which we covered in class time and time again. Refer back to your notes. So, this oxygen, I need to take a lone pair off of it. The reason I did that is because if I left that lone pair there, you would count it up and see you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. And that breaks the octet rule, and as you know, oxygen will not break the octet rule, so we will take that away. Alright. Now, don't forget the other atom that's involved in that bond. Nitrogen, for example. Looky here, count this up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm showing 10 electrons there as well, so I have got to take out one of those lone pairs. Now, count everything up and make for sure that you're showing 24 valence electrons. I'm going to count by 2 again, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Awesome, but you're not finished. Do not forget resonance structures. So in this case, I have 2 other resonance structures. There's 3 structures total. How do I know that? There's 3 places I could have put that double bond. So I need 2 more structures. Remember, I just did the arrow method. And I just like to just take my double bond and just shift it around there. So this one, this oxygen, needs, these 2 oxygen needs 3 lone pairs, while this oxygen in the bottom needs 2. It just follows with the double bond, and that nitrogen's good with those bonds it has us around it. And then our last Lewis structure. So, the double bond out to the right. Okay. Now, you're finished, except for, remember, we got to circle our final answer. Sorry, I forgot to do that over here. You're finished unless I ask you the question to show charges. Oh man, misspelling today. Charges. Where they apply. Okay, this is a good way to check yourself. Remember, in your final Lewis structures, I do not want to see these bonds broken. This right here is what I want to see, but with charges on them. I'm not going to break these. If you need to break these, do it. But you got to remember, this is separate from the octet rule. It is not like counting up the octet rule. It's different. It's like I got 2 electrons sitting here because there's 2 bonds, and on this one I got 1 electron here for this oxygen because there's 1 bond. So count this up. This oxygen normally starts with 6 valence electrons, and it has 1, 2, 3, 4, 5, 6. It's neutral, so that's fine. So come to this oxygen. It has 1, 2, 3, 4, 5, 6, 7. It has 7 electrons, 7 valence electrons. That's 1 more than normal, so it has this negative charge. And if you count up on this other oxygen over here, it's the same thing, so it has a negative charge. Don't mess up. You're not finished. Take a look. Always look at your overall charge. Your subcharges will add up to equal your overall charge. Your overall charge is negative. Right now, you're showing 2 negatives. Has to be a positive somewhere in there to get this back to where it's a -1. So don't forget your center atom. Nitrogen, for example, here as we got, normally has 5 valence electrons. So count it up. 1, 2, 3, 4. It has 1 less than normal. So, nitrogen has a positive charge. You need to show this on all of your Lewis structures, so you know the nitrogen is going to be positive charged in all these. But then follow these single bonded oxygens and make sure to give them their negative signs. And then that's it. So, don't forget to show resonance structures where they apply. Don't forget, if I ask you to show charges where they apply, to do that. And don't get tricked up on my little tricks that I throw out there, like this here. Okay? A lot of y'all would have messed up right here. You would have just put a negative sign on one of those oxygens and said, hey, we're finished. Don't get caught up on that. Make sure and follow the steps. Take your time and work through this. And also, do not forget your notes. Guys, look at your notes. Look at stuff we've done. This is not all going to comprise of Lewis structures. So make for sure you take a look at it. If you got any questions, remember my door will be open in the morning and you can come in and ask me questions, and you're more than welcome to come in during lunch and ask questions. If not, then I'll see you in class tomorrow.